Hi again, everyone. It is 3:30 Pacific time on Thursday, and we are back live with you. I'm Jill Zandy. I'm the Executive Director of Mate Inspiration for Innovation, and I'm also the Mate ROV Competition Coordinator. I'm here with Matt Gardner.
Hi, everyone.
Matt is the Competition Technical Manager, and behind the camera is Newman Burial. Wave, Newman. There's Newman. He's one of our C-Mate students working hard in our store. We pulled him out to be the cameraman for this Facebook Live. So you might have been with us earlier when Matt took us all through the Ranger class props and gave some really great information on the mission tasks. Now we're back and we're going to go through the Explorer class. So this is the Explorer class prop demonstration and question and answer, which means, you likely know this, you can ask questions and Matt will answer them live, right here, right now. So exciting. So some reminders: subscribe, so you don't miss any time that we go live. And also, again, a reminder, this video is going to live on our competition Facebook page, and it's also going to be recorded and posted to our YouTube channel and our Vimeo channel. So you will be able to access it. I'll get the links out there as soon as they're ready. But if you missed something, if you want to watch it again, if you completely missed it and need to see it, you will be able to. So no worries about that. I think that's it. One thing I did want to mention, so a little hint here. We have developed a partnership with Microsoft. Yes.
Oh, yeah?
The Microsoft. So coming soon for Explorer class teams, there's going to be a little challenge that we are working on with Microsoft that will challenge you to use some of their products in our mission task or for some mission that you might come up with on your own. That's all I'm going to say for now. We'll give some little hints during this Facebook Live, and then next week we should be able to launch this and put it out there for all of you to see. But I wanted to give you a hint. So shout out to Microsoft and stay tuned. Anyway, okay, without further ado, I'm going to turn it over to Matt Gardner for the prop demo.
Okay, and we are going to get going on this. So I'm going to actually go through the mission props in order, the order they are in the manual. But I'm going to talk about the order, some at the end and some during there, because during the as we go along, because you don't have to, when you're in the water, start with task one, go through that, then you get tested. You can kind of pretty much do anything, anywhere you want. Also, as we go through this, you can be asking questions, but I know a number of you have been asking questions on the forum boards, which is great. I got them all answered a couple days ago, and I'll hopefully get to them again tomorrow or next week. But one thing I will say is, there's a lot of questions on the forum board. Sometime in the next month or two, probably March, early April, I'm going to try and get kind of a synopsis of all the decisions that we made on the forum board, and I'll get that up on the forum, probably pin it up top so everyone can kind of look and see if there are any big decisions made, what they are. So anyway, we're going to get started with task one, ensuring public safety, the dam inspection and repair. And so this has this task one kind of has four different things. There is the inspect the foundation of the dam, repair the damaged trash rack, insert grout into the void, and inspect the inside of the pipe. And for this, as I said, order, you can do any one you want first, but we're going to do it in order. So we're going to start with inspecting the foundation of the dam. So the foundation of the dam is going to be hanging in the pool about 1.5 meters, 1.25 meters out from the side. And the working side is actually going to be facing the pool. So you're going to have to maneuver in behind it and do all the work. Now, to save a little space here, so Newman and I are both crowded back here, I'm going to turn it around, but again, on the pool day, it's going to be hanging up in the pool. So here is one of the foundation of the dam, and the first part of this is following the transect line. So you are going to follow the red transect line from start to finish, and the starting point is either going to be the red square or the red circle, and the station judge is going to tell you which one it is. So in this instance, we're going to say the square is the starting point. So you're going to maneuver your vehicle so you can see through it, starting at the square, going to the circle, following the red line. And what you want to do is have it so you can actually see a whole square. But we want you close enough so that you're actually following the line so that you can only see essentially one whole square. So if you get it so the camera is so far back that you see two squares and you move it. So I'm going to borrow the camera from Newman just to demonstrate this. So essentially, as you go through, that would be good because you can see one whole square. You can't quite see this whole square. So you'd follow it going along, then up and down. Okay? So now for Explorer class, we've challenged you to do a couple things here. And one of that is you can do this autonomously. So what that would mean is you would come, so you are looking at the square, which we said was a starting point, and then you go hands-free. So anyone in the pilot station, hands off computer, hands off controls, and you have your control system autonomously follow the red line, coming up and down, again, staying close enough that you're not seeing the whole thing. Because, you know, we don't want you just with a wide-angle view going, yep, there's the whole thing, I see it, I don't have to follow. We want you actually to be moving your vehicle through the waterfall line. So you're going to follow it autonomously. So again, hands off until you get all the way to the end. Now, if your program messes up, and let's say you're going along and all of a sudden, whoops, it stops following the red line, you can start over. Just tell the judge, hey, our program messed up, we're going to pilot back to the start. Try it again. Try it again. You go hands-free and let it go through again. But once you have it following, start to finish, you get the points for full. Now, if you don't have autonomous control, you can also do it manually. So less points, but you can pilot up to here and just manually pilot through here. Again, that's for less points.
Hey Matt, real quick question. How deep is the line in the pool? Like, what's the range? The depth range for the line?
How deep is this going to be? It's probably going to be, the top's probably going to be 1 meter, so it's probably going to be about between 1 meter and 2.5 meters down in the pool. So we're not going all the way down, but it's not going to be right at the surface, so at least 1 meter down.
See.
Okay. So let me see where I am, and again, I'm going to be following notes. This is my 4th one of these in 50-something hours.
But you ate your Wheaties today.
I did, yeah. Okay. So again, that's part of it. Now, the next part is locating and gathering information about the length of the crack. So on here, there's going to be one crack. It's going to be blue, a blue line, and as we said in the manual, it's going to be parallel to the red line. Not going to be intersecting the red line. It's going to be all the way within one of these squares. So, again, you can do this a couple ways. And I just also want to say, you can do it on your first try through, or if you say, you know what, the first time through, we want to get those points for following the line, you can follow the line, and then say, okay, now we're going to reset, and this time we're going to look for the blue line, the blue crack. Or you could just, hey, the first time through, you have the program to do it. And again, as I said, you can do this autonomously, you can do it all manually, or you can do a little mix. So I'm going to go through these. So fully autonomous determination of length concurrent with autonomous line following. What that means is you come at the start point, you go completely hands-free, your vehicle, ROV is following this red line, and when it sees this crack, this blue line on there, no pilot's touching anything, it identifies it, and puts the length of it on the screen. So essentially for this one, it would put however long this is, would come up on the video display. And so that would be fully autonomous. Again, everyone is hands-free. So the key is your ROV is autonomously following the line. Your ROV autonomously determines and displays the length of that crack. So you would put up, for instance, if this one was 23.2 centimeters, what you measure at, you'd put a 23.2 cm overlay on your screen. Okay? Now,
question.
Yes, question.
Can we, trying to insert some energy here.
Yeah.
We are tired, it's been long. Can we take a look at the whole board before starting the autonomous mission? Well, the board's going to be in the water.
Yeah, the board's going to be in the water, and it's going to be close to the wall. So really, no, everything needs to be done as you're going through it. So you can't sit way back, look at it, and make your determinations then. Okay? For at least for full autonomous. So the next kind of step down is autonomous determination of length, but with manual control. And this would kind of be what they were talking about. If you drive up to this crack so you know it's here, and you manually drive up so your camera is pointing at this, but then your program, excuse me, then your program looks at this and says, hey, this crack, this line is, 22.3 centimeters long. You could do that, but if you're driving it, but your program does that, you're getting not quite as many points. So that would be autonomous line determination, but with manual control. Okay? And then the last kind of, I would say, worth the lowest points is if you're doing a manual determination of the crack. So that would be you driving up, so your pilot comes up and looks at this, and then maybe you're holding a ruler there, maybe it's somewhere else, but if you don't have a program to determine how long this crack is, that would be manual determination. So some of the keys for this is you don't have a program to determine and show the length of the line. You've manually driven up. So this is in your video screen. And if you actually have to tell, if you are telling the judge, hey, this line is 22.3 centimeters long, that means you've done it manually. In order to do it non-manually, you need your program to throw that up on the screen. Okay?
All right, so we have a really good question. It is, can we look at the props before the mission and fine-tune our value? So I almost feel like it's a calibration, if you will. So we may want to consider having something, you know, top side that's not, I mean, that's going to be in the water.
Right. Right. So what I'm thinking and what I'm going to have you do is, as I said, I'm going to have you ask this or put this on the forum, and I will talk to our engineering team. But what I'm thinking, what I'm going to pitch to them in support of, is we'll probably have something like this in the practice area. So we'll make an extra one of these. It'll be hanging in the practice area. It'll be different, so it's not the actual one you're seeing on the mission, because if you read the manual, there's like 6 different designs it could be. And we'll have one of those so you can practice there, design it there, or sorry, not design it there, but you have it to kind of calibrate your system.
Hey, and you know what, this is amazing, but we just got a shout out from Christian, who's in Switzerland.
Hey, Christian.
Hey, we've never had a team from Switzerland, Christian, so if you are part of the team from Switzerland, this is exciting for us, and we will need to get your flag so we can fly it at the the World Championship here. So the question is, how's the lighting going to be on the board?
It's the lighting of the pool. Now, it is an indoor pool, but there's pretty good light, a lot of windows. But my recommendation is if you think you need lights, you put lights on your ROV to get the lighting that you want.
Good answer.
Other questions?
No,
okay.
Not right now.
So, the next part is going to be mapping the location of the crack. And again, we're allowing you to do this autonomously or manually. So autonomously would be, you know, you're going along, you've seen the crack, you've got its length, and then, totally hands-free, on a screen, a grid pops up, which will be, there'll always be 4 across, 3 down, so 4 squares. And that grid pops up, and it puts the distance, the length, 22.3, I think I'm calling this, would pop up in the right box. So, you know, it pops up, and it would be the second box over on the top row. Would be fully autonomous. Again, pilot's hands-free. Now, if you can't do that, you can also do it manually. So, if you want, there will be a grid here in the top, and at least for this one, you would just put a line or 22.3 centimeters in the right box, and you get points for doing it manually. But just kind of a review for full points, and this is kind of what we're looking for full points, is a truly hands-free run. So what you do is you could pilot up to the starting point, and then you go hands-free. All the pilots, people in the piloting station, hands-free, and your vehicle follows the red line from start to finish. When it sees that blue mark, that blue crack, it determines the distance autonomously, again, no one touching it. So essentially, as it's going through, it says, hey, there's a blue mark, measures it as 22.3, puts up a 22.3 there, goes through, and then that would pop up on a map. And honestly, I'm thinking a little hint for those watching, you could probably, as you're going through this, if you just have your little grid pop up with 22.3, that's what the judge needs to see. The judge needs to see that distance 22.3 pop up on the screen. Okay? And again, if you're doing more things manually, you get fewer points, but it's all doable.
Hey Matt, can I ask you a question? And I remember talking about this. If they take a screenshot to know the length of the crack, is this still considered autonomous? So they take a screenshot and then they're programmed.
So yeah, if you take a screenshot of this, feed that screenshot over to something else, yeah, that is autonomous. Now, let the judge know if you need to like hit one button for that, that'd be okay. Just say, hey judge, I'm hitting this button, but we don't want you doing a lot of typing or anything like that. But if you could take a screenshot and do it there, yes, that's still autonomous.
Got a couple more questions.
Okay.
Should I stop with my camera viewing the circle or the square, or can I totally get out of the red area then stop? Speaking about
autonomous. Oh, yeah, so let's say you're starting at the red square, going circle. Yeah, if you go through this, you hit the red circle, and then your vehicle keeps going up, yeah, that's fine. You don't actually have to stop here. Now, again, let the judge know, hey, we're coming up to the end here, there's a circle, and we're done. Essentially, if you've gone through autonomously, you see the circle, and you've done the line length, then you can go back hands-on and keep going on those other tasks.
Got it. This is a really good question, this next one. Does the crack need to be in the exact same spot in the grid, so like where it is in the square, or is it fine just to be just right in the box, whatever box?
So if you have, again, I didn't actually measure this, but if this is 22.3 centimeters, if that pops up anywhere in this box, so on this one, it's a little more on this side. If you had the 22.3 pop up here, down on this side of the box, that's okay. As long as your length measurement pops up in the proper box, you're good.
All right, and one more, and I love this. Mark, you're our top fan, or so it says. Does the autonomous mapping need to include an image of the red line plus blue line, or just the number in the correct box?
No, so you don't need the red line or the blue line. You just need the number, and I'll have to double check now. I think we said the number needs to be in blue font, which shouldn't be too hard, popping up in that box. So no, you don't need to put the red line on there.
Cool. Those are great questions.
Yeah.
Those are really great questions. Okay, that's it for now.
Okay.
Take a drink of water and...
Yeah, that's the nice thing about questions. It allows me to get a drink of water.
Take a pause.
So real quick on this, before we go on, is some documentation. If your company is planning on doing this autonomously, we're going to require some documentation beforehand. I'm not going to go through all that. Check your manual. What we want is listed in there. It's down in the documentation section, which is 6.1 point something, I believe. So is the submission information. But here's the thing, if you don't submit that documentation beforehand, you're not going to be able to do autonomous control flow. If you just show up at the international competition and say, hey, we're going to do autonomous, and we don't have that documentation from you, you're not going to be able to do it. Okay? So moving on to the next part of this task.
Wait, question. Can we use deep learning?
Yes, I don't know what that is, but yes, we can.
Sure.
We don't have any required programs. If you are doing it, you can use whatever you want.
Or they might want to look at next week when we put that Microsoft challenge out there, because there might be a tool that you'll have access to that could help you accomplish this. Just take it.
Okay. So the next part of this mission, again, this don't have to be done in order, is inserting grout into the void. So the void is going to be a red cup. We have a little base, and inside there's going to be a little line that marks where you have to fill it to. That'll be on the bottom, and on the surface, you are going to have a number of rocks, Mexican beach pebbles. They'll be in a container, but the container stays on the surface. So you need to create a container or some way to carry these rocks down and fill this so that line is completely, you've got it filled completely with that line. So there you go. And again, the judge isn't going to be, through your camera looking, but, as long as you get enough in there so it's over the line, you're good to go. Now, a question we had earlier is if you spill some of these on the outside as you're doing this, so let's say your problem in here comes out, that's okay. They don't all have to be in the cup. But again, you only have so many rocks. So if you spill a bunch of them outside, you may have to go pick them up if you want to fill it. Okay? So the next part is repairing the damaged trash rack. So the damaged trash rack is going to be down on the bottom. So there is the trash rack, and here's the damaged trash rack screen. It's missing most of this middle post, and it's going to be laying there. And your job is to get this one back to the surface, and then on the surface, you are going to have a new one that you have to carry down. So if you want, you can come down, pick this one up, bring it to the surface, bring this one down and put it in there. Or, little hint, although it's not much of a hint, you could bring this one down, hold it while you pick this one up, put that one in, and bring this one back. So essentially, the damaged one has to come up, the new one has to be in there. Now, to be properly in here, the bottom part needs to be in the cradle. It needs to be leaning up against this bar, and it needs to be released, completely released from the ROV. So the nice thing is, even if you get a little bit off, it'll still be in the cradle. So it can be over that far. Whoop, that's a little too far. Like that, and it'll still stay up there. But to get the point, the bottom part has to be in the cradle, leaning up against this, free of the ROV.
Hey, got a question about the grout, and I think we had this question during the Ranger prop demo. Does it have to be carried with the cup you guys provided? We don't
yeah, we are not providing you with a cup. We're providing you with a cup you have to fill up, and we'll have grout. It may be in a cup like this, it may not, but no, you cannot use a cup on the surface full. You need to design a container to carry the grout down.
And a follow-on question, can we leave our container for the grout after we fill the cup? What if they leave it on the bottom?
No, so if you design, since you're designing the cup, it's not one of the main props, it would be considered debris if left in the pool at the end of the mission time. So if you did leave it down there, there's, I believe, 5-point penalty for leaving debris. And if you leave a bunch of debris, it's a bunch of penalties. Okay. So, and this is going to be another time we get lots of questions. The next one is deploying the micro ROV to inspect the pipe for muddy water flow. So actually, here's I'm going to ask something this time. So we just did this with Ranger. We got a lot of questions through. I'm going to run through this, and then at the end, maybe like a minute from the end, I'll say, hey, start asking your questions, because I might answer your question partway through. So let's just try that, but like I said, we'll give everyone a chance to post their questions. So the pipe is going to be on the bottom. It's going to be as flat as possible. Now, we're not going to have any ups and downs in it, but if your pool has things on the bottom, there may be a little bit of up and down, but it's going to be flat. It's going to be slightly curved. Now in the manual, we had a radius, bend radius, but in general, what we're looking for is we just want it bent enough so that you actually have to travel into it to see the muddy water flow at the end. So on this one, the muddy water flow is going to be back at this end. My guess is you have to get probably a little more than halfway before you can see that down there. So that's our goal, is we want that micro ROV moving through the pipe to see that, okay? So there are going to be the area of muddy water flow in the pipe. It's going to be down at this end. I have a chunk left out. So again, it's just going to be this brown foam, and all you have to do to get points for this is show the station judge in your micro ROV camera that you see this muddy flow. And every pipe is going to have a muddy flow, so it's not like you're going to get down there and there isn't going to be one. Okay, but you need to see this to get your points. Now, again, we have extra points if you're using fiber optic cables, which means the only thing between your primary ROV and your micro ROV, the only thing sending communications is fiber optic cable. So that would mean onboard power, fiber optics, carrying all signals between there. Now, if you have a rope or a line to maybe provide strength and reinforcement for those cables, that's okay. You could even have copper wire next to it, but if you're using copper wire in conjunction, you have to prove to the safety judges and the mission judges that those copper wires are not carrying any signals. And it may be the judges that I want you to cut it there and there, because all signals have to be carried through that. So at the end, and I'll come back and talk a little bit more about this, but after you have ventured into here and come back out, you need to dock your micro ROV back with your primary ROV. And what that means is it needs to be kind of nestled in there. It doesn't have to be rock solid tight, but it can't be loose hanging out in the water, and it's tethered. So whatever cabling you have between the primary ROV and the micro ROV can't be dangling out. That all needs to be in there. So just some other notes, and tell you what, now's a good time to start typing in your questions as I go through these other notes. It must be a vehicle, so you can't have an endoscope or other extension off your primary ROV that reaches in here. It needs to be a vehicle.
It's recording video right now.
So good again?
Let's see. I think we're...
Okay, sorry, we might have had a little hiccup.
It's good now.
Is that good?
It's good now, yeah.
Yay, we had a hiccup. Sorry, everybody.
Okay, well, we might have had we did have a little hiccup there, which is going to happen now and then, but I'll tell you all the important things during that time. So anyway, it must be a vehicle. So your micro ROV can't do other tasks when it's not docked to your ROV. So if it's loose, this is the only task it can do when it's away from the vehicle. So later on, as you're doing other tasks, you can't use your micro ROV to drive away and maybe like look at the cannon or do something like that. The micro ROV can only be away from your primary ROV for this mission. And if your micro ROV isn't docked, you actually can't do other missions. You can't get points for other missions unless your micro ROV is docked. Now, if for some reason you're like, oh my gosh, I can't get this thing docked, but I still want to go on and do missions, you could drive it up the surface, dock it by hand, remove it by hand. That's okay. You wouldn't get points for docking it, but then you could go on and get some other missions. One last thing, or I might have a couple more. The micro ROV thrusters do not need to be shrouded. Okay? So that's it for me. I assume we have like 500 questions here.
Hold on a second. Okay, so let me go down here. Okay. So, yeah, there's several. I'm going to start at the top. Some of these have to do with the grout. Oh, yikes. Sorry. Let me see. Oh, sorry. If we use a fish net for the grout, can we leave it with the grout in the cup without retrieving it?
No, if whatever container you're using, fish net, other container, that would constitute debris. So if you left it there with the grout, it would be a 5-point penalty for leaving debris in the pool.
Okay, and then another question about grout. What is the necessary grout volume to be inserted?
Oh my gosh, look in the manual. I don't remember off the top of my head.
Okay,
I believe it's 400 milliliters, but it's like in the manual. I don't know what it is off the top of my head.
Okay, so back now to the muddy flow. In the manual it said the muddy water flow is 10 centimeter but 7 centimeter in prop instructions. Which one should we expect in the competition?
Is that the, oh my gosh, I think we said it's set, I'll have to look, but I think it said it was set 10 centimeters from this side, but this might be 7 centimeters.
Well, yeah,
post that to the board. I'll have to look at the manual and the prop instructions to see what was written where. But essentially, it's going to be, we're not making this so small that you can't see it in there. Our goal is you're driving in here, see this nice big obvious thing, show the judge and get your points.
Okay, and another question from Ken. That means we can power our micro ROV with a copper wire and signal it with fiber optics.
If you are powering it with copper and signaling it with fiber optics, that would not be a fiber optic. If you have a fiber optic ROV, the only connection for any signals, power, electricity, whatever, has to be through fiber optics. So no, if you are powering it from copper and sending signals through fiber optics, that would be a normal copper wire ROV, not a fiber optic ROV.
Got it. And okay, Jackson from URI Robotics, would a subsea monster truck be allowable?
Yes, yeah, we actually had that written in Ranger. You don't need a propeller or thrusters. Someone in the Ranger asked, can you have wheels? Yeah, you can have wheels, tracks, whatever you want. So yeah, if you have a little RC vehicle or whatever. Now here's the thing.
It has to fit in the hole.
Sorry, it has to fit in the hole, of course. But any motors you're using have to be waterproofed. So we said motors, propellers at least, don't have to be shrouded, but everything has to be waterproofed.
Okay. Can we pull the micro ROV from the tether to dock it?
So you can't pull anything by hand, but if you have a motor or something that reels it back in, yeah, that is fine, but it can't be pulled in by hand.
Okay, back to that grout. How do we show the judge that the grout is fully over the black line? Are there anything specific we need to show in the camera?
No, so essentially, as you look in here, just show that with the camera, and the judge will tell you yes or no. So if you know, the judge isn't going to probably ask you to go all the way around, but you know, it's my thought is going to be pretty obvious. It's like, hey, you filled it up. The judge will say, hey, that's enough. You're done. Go on.
Hold on, I had to do a little refresh here. Sorry, let me get back because I was hung up. All right, can we leave the micro ROV to the surface when we finish the task?
Yeah, so we actually had a similar question in Ranger. When you're done with this task, you can bring your primary ROV up and remove the micro ROV. Another question we had earlier is, does the micro ROV have to be on the ROV at the start? And no, so if you want to go do some tasks, come back up, plug in your micro ROV, come do this task, go back up, remove the micro ROV. Yeah, you can do that.
Got it. Okay, so can we use the micro ROV camera while it is docked to our main ROV?
Yes, so when your main ROV is, when your micro ROV is docked, yeah, you can actually use your camera, and if you need to, you can use that thruster on there to move you around. So as long as it's docked and the tether isn't hanging out, you can use the systems of it to do other things.
Got it. And Jackson and Jordan from URI Robotics are really excited about the monster truck idea.
Okay.
So you guys have to you know,
bling it
decorate it, bling it out. Right, I was looking for the right word, the appropriate word to use. Yeah, bling it out. We want to see it, right? Give us some personality if you're going that route. Okay, another question. Can we attach a rope or anything in addition to the main tether between the micro ROV and the main ROV? Would we still get the full points for using fiber?
Yeah, so if you have something in there such as rope, line, that's not carrying any signal, so as I kind of said earlier, you could even use copper wire, but you have to prove that copper wire isn't carrying any signals, sorry. Yeah, you could use that as a strengthening, whatever you want. So yeah, rope, things like that are fine to strengthen and maybe to pull in, because you probably don't want to be pulling on your fiber optic cables. That's fine, but again, if it's anything that could potentially carry signals or electricity, you have to prove to both the safety judges, safety inspectors, and station judges that that's not carrying any signal.
Got it. We're good for right now.
Okay.
Ooh,
okay, so I believe, let me get back to my notes, I believe that's it for task 1. Now again, if you have questions, we'll go for it. And we're moving on to task 2, maintaining healthy waterways. And the first thing you have to do, or you can do it out of order, but is to measure the water temperature. So you're going to measure the temperature somewhere near your pH sample. Now, we don't have a distance. It doesn't have to be within 30 centimeters, 50 centimeters, anything like that. But you want it close enough. So, turn that on now, but you're going to bring a temperature sensor down, and just have it in this vicinity. Just going to leave it there. Now, this could be carried on your ROV. And then, of course, you are going to get a reading. So right now, we're getting 21.3. Now, a few things, of course, being scientists, we're doing everything in Celsius. So if you, for some reason, report in Fahrenheit, it's not something you want to do. Now, I'm going to skip ahead a bit because we have a data sheet that you need to fill out with all this information. And I'm thinking, a little hint is, you've got your temperature, let's fill it out. So, of course, I've forgotten, I think it was 21.3. So in the box for water temperature, I'm going to write 21.3. There's also some other information which you could fill in beforehand, which is your company number. I'm going to be company 1. Company name is Matco. The date is the 17th, I believe. Someone yell at me if I'm wrong.
Yeah, 17th.
And the time is 4 o'clock-ish, at least Pacific time. So you could fill that in beforehand, but now, as I said, we're going to fill that temperature in as we go. Okay?
And then Matt, they could also fill out all of the other team information and date in advance.
Yeah, you can fill that out in advance because that's not going to change.
And then another question here, where will the benchmark temperature sensor be placed?
It will be probably somewhere on the side of this bucket. Yep. So you just have to get down near the bucket. And again, if you see that our benchmark sensor, which will actually probably look exactly like this, you know, if this is sitting right here, I'd recommend coming up right next to it and getting your temperature and sensor there.
I mean, it'll be visible.
Yeah, it'll be visible. It won't be hidden. Okay, where are we?
Oh gosh. If we power the micro ROV from the main ROV and use fiber optics in order to send signal only, would we have 10 points? 10 bonus points.
No, because to power, the only way you could get power there from your primary ROV to that would be copper wiring, which wouldn't be. So if you're using fiber optic, you pretty much have to do onboard power. And again, there are not lots of specs for the non-ROV device in there, and only fiber optic cables carrying signal between there.
And then there's another question: is there a range for the temperature? Like, are we talking 0 to?
Well, we're not going to be changing the temperature, so a little hint for everyone. For us, it's going to be the temperature of the pool right in there. So
whatever the pool temperature is, yeah, we don't know.
Temperature is, which my guess is going to be, well, you know, people swim in it, so it's not going to be freezing. And it's not going to be boiling yet. But no, it's going to be in that range. Okay, so the next part is...
the time. So he asked about the time. So the time, we will actually, Hassan, in Kingsport, Tennessee, we will actually be on Eastern time, not Pacific time. So when you fill out your data sheet, you should use the time in Kingsport, Tennessee on the data sheet.
And when you get the schedule, we'll have the time of your mission run. So, you know, if the mission run says you're going at 11 a.m., I'd write 11 a.m. on there.
Yep.
Even if we get a little delayed and you actually are going at 11:15 and you don't actually get your temperature, or you don't even start measuring until 11:25, yeah, you can write 11 o'clock if that's your time.
Got it.
Okay, so the next part is measuring pH down here. So the sample liquid, it's going to be inside a 2-gallon bucket, inside a soft water bottle. So let's see it. So you can see there the soft water bottle down inside there. Got a 3/4 inch female and male coupler there. So actually I'll show you. You can see the pictures of this, but male coupler attached to a female coupler. And then on the top of this we have just a little bit of thin plastic wrap, and that's mainly just to keep the substance inside here, the liquid inside here, from mixing with the pool water before you get here. So what you're going to have to do is you're going to have to push through this plastic wrap, and you know you're not allowed anything really sharp, but you really don't need anything sharp. So you know, even a pen like this can easily puncture through there and get down to the sample inside. Okay, and just a couple other things. You know, every team is going to get a new one, so there aren't going to already be holes in there. But again, you don't want to be too sharp. Now, what is too sharp? If it's going to injure a diver, you know, if I do this, it doesn't really hurt. But you don't want anything so sharp that it could injure someone by bumping into them. And for what this plastic is, it's just simple plastic wrap I got from the store. I'm using just some simple glad and clean up.
Hey, how far will the container be filled with the sample?
It's going to be full, so it's going to be all the way full. So generally, the minute you push into here, you should be down in the sample. Of course, pushing into here, you may have contaminated a little bit, so I'd maybe recommend going a little deeper just to get a little bit better sample down there. And then, of course, you are going to have to show the judge whatever reading you get. Now, a few other rules is it has to be done in the water, so you can't pump liquid from here up to the surface and do your reading on the surface. Or sorry, do your pH test on the surface. It has to be done in the pool. But you could pump water from here onto your ROV and do your test on your ROV. A couple other things. At least some of the pH sensors we've looked at online are glass. So if you have a glass pH sensor, we want you to protect it somehow. You know, maybe glue it inside a plastic tube or something like that, so that if it gets damaged, it's not going to fall, no glass in the pool. It's not going to fall out and leave glass chunks in the pool.
Safety first.
Safety first.
Do they need to test how strong the wrap is before the run?
We
could have some plastic wrap on the...
Yeah. Well, honestly, I will have probably a 200 square foot roll of this, or maybe a little less, and I only need about that much per time, and there'll be 30 teams going twice, 60, I'll probably have 70. So yeah, we'll have some plastic wrap. I'll have some plastic wrap around so you can see how hard you have to push.
Okay, another question. What is the density of the liquid in the container?
It's going to be near water, probably a little bit salty. So it does stay, because salty it'll stay down in there a little better, but it's not going to be much different than water.
Fresh water.
Fresh water. Well, it'll be salt water, because that means if you do penetrate through there, it's going to stay. It should stay down, be a little heavier than pool water.
Okay.
Okay.
That's it for now.
Whew. So powering on through. So the next part is determining habitat diversity. Lifting a rock to see the benthic species underneath. So the rock is just going to be a chunk of PVC with some plastic attached. And what you need to do to get points is lift this up. So it needs to be up off the bottom and off this sample and under control of your ROV. So if you just push this off, that wouldn't count because you never had it up off the bottom under control of your ROV. But once you've got it even that far off, you're good. You can set it down here. You could bring it back if you want, but you can just set it down right there. And then once you have it, we have the benthic samples underneath. And so again, we have a couple ways you can do this. Now you can just look at this in a video screen and use a handbook. So we have a benthic species handbook. This is a Ranger one, but Explorer one's exactly the same except for that word right there. And actually, if you're looking, hey, where is this? We've, in the last couple days, posted this to the competition website. So you can find it there. And on the back of it, it just has the 4 potential species. And if you're doing this with a handbook, you would look at this. And again, oh, sorry, let me write down, let's say our pH was 8.1. So I'm going to write that down because we want to write it down. And then if you're doing this just with a handbook and a video screen in your brain, you would look at this and go, species A, there are 4 triangles. Species B, which is a square, there's 1. Species C, rectangle 1. Species D, circle, there are 3. And you'd be good. Or we've also challenged you once again to use image recognition to do this. Excuse me. So if you plan to do image recognition method, again, you want to go hands-free. So once you've removed this rock, you can maneuver your vehicle so it's getting a look at this from the camera you want. But then you need to go hands-free, okay? And during that time, you know, don't want to type in numbers into a computer. Want to make sure you're doing this. So hands-off controller, and then your computer will output, and you can look at the manual and see what the output should look like. So, for instance, for this, you would have, your output would be a triangle and a number 4 next to it, because there are 4 triangles, a square with a 1 next to it, a rectangle or line with a 1 next to it, and a circle with 3 next to it. So that's the output we want to see, again, hands-free. Okay? Something I also want to say, if you want to practice with this, we just published what we're calling a benthic species template, which is an image with these and a little size next to it. So if you want to practice this, you can download that, cut and paste in whatever art program you like, put a bunch on a piece of paper, print that out, make sure it's the right size, and either do it in the air or tape it to something and put it in a pool. So you can practice.
Can I ask you
Yes.
some questions? Okay, this is back to the liquid in the container. Is the liquid viscous?
No, it'll be water with some stuff in it to make it a different pH.
Yeah. Okay. Perfect. So it'll be able to flow through a
Yes. It'll, like I say, you know, salt water is probably technically a little more viscous, but it will be pretty similar to salt water.
Cool. Okay, the next question. The sheet for the rock is said to be 32 centimeter by 20 centimeter by 28 centimeter by 18 centimeter as well. I'm not sure what, is there a discrepancy?
Well, so no, the rock is one. I think, I don't have the in front of me, but the rock is one of those, and the sample underneath is the other one. I believe the sample's 22 by 18 or 19, and this is 30-something by 20-something. So
the rock is not the same shape as not the same dimension.
Right, the rock is bigger, so it completely covers the benthic sample. I think that's where you're wrong. If there are 2 discrepancies, you know, if we have 2 different ones for this, put it on the forum board and I'll clear it up and measure this at a later time and answer that for you.
Perfect. Also, will there be any angular displacement of the shapes for the shapes?
Yeah, so the shapes could be rotated, doesn't matter for the circle, but yeah, it could be, the triangles could be rotated around as needed.
Okay.
And sorry, and another thing is, you can position yourself anywhere you want. So, if you say, oh, I always want to look at it this way, you could do that. But, it's kind of up to you to position your vehicle.
Yeah, and so Ken, I see you noted that there's a typo. If you can look, like Matt said, if there's a discrepancy and you can point that out on the FAQ board, we'd love that, because then Matt can go through and we'll make sure to fix things. So I got some more questions, Matt. Is there no reference temperature sensor in the water sample? If there is no reference temperature sensor in the water sample, can we simply measure the pool water temperature somewhere on our ROV and not in the actual water sample? Or does the temperature sensor need to be stuck into the water sample to get points?
Your temperature sensor needs to be somewhere in this vicinity. So, if you want to measure it here, that's fine, but our benchmark is going to be where our temperature sensor is.
It probably should be close to our benchmark.
Within, close to our benchmark. Yeah, if you're measuring up here, that's not going to count.
Okay, so, and we got this during Ranger. Can I take a screenshot and draw a region of interest with my mouse?
Yeah, so if you take a screenshot, draw a region of interest with your mouse, as long as again, what we're really looking for is you're not, typing in numbers and you're not secretly using your brain to type in the numbers. But yeah, you can do things like that.
Okay, so back to the micro ROV. If the micro ROV is attached, can we also use the micro ROV camera for image recognition?
Yeah, so you could use, as long as it's docked, you can use that micro ROV camera for image recognition. Okay, if there are other questions, we'll get to them.
Yep.
But, so again, just kind of like the line following recognition there, if you're planning to use image recognition on the benthic species, we require some documentation in advance. And this is actually the kind of pre-test, pre-evaluation we're going to do at the International. So you are going to have to test your system in the air. For those of you who did this last year, it's going to be similar to that with this. So how that test is going to work is you're going to set your vehicle down, get it prepped however you want, and then you're going to go hands-free and back away. And a judge is going to hold a sample up in front of whatever camera you want. You can tell the judge, hey, we need it right here at this camera. And then you're going to have to test. It's going to be a test of your system to make sure that you have a working system. Okay? And again, if you don't turn in documentation, you can't do the test. If you can't identify anything on the test, if your system isn't working at all, you're not going to be able to do it in the water.
Hey, so Hassan says, and I think this was his original question, they don't have to measure the temperature in the
No, yeah. You're not measuring the temperature of the sample you're getting at pH, you're measuring temperature of the pool water in the vicinity of this.
Yeah, thank you.
Yeah. I kind of figured that might be what he meant, but I wasn't sure.
Yep.
Okay.
Wait a second. All right. For the line follower, what will be the thickness of the grid line?
Okay. The grid lines are, these grid lines are probably going to vary by a millimeter or two because they're just done with marker. The tape itself, the thickness was provided. I think it's 1.8 or 1.9 centimeters. But if you look at this, this line's a little bit thicker there than here. So I wouldn't recommend using the width of the grid lines to do that. Although each square is 30 centimeters by 30 centimeters, plus or minus a millimeter maybe or two. Okay.
Okay.
So, again, as you're going along, you're getting your data, you want to write it all down, and once you have all the data you've collected, show the judge, not really turning it into the judge, but show the judge. You have to show this, turn it into the judge during the mission run. So if your time is up, as you're cleaning up, you go, oh, judge, we had these. Too bad. You actually need to get this, you need to do all this and write it down during your 15-minute mission time. Okay. And one other thing on the data is write down the data that you collected. So let's say you got a pH, you said the pH was 4.2, and it was actually 2.9 and you are outside the correct range, you know, you won't get points for the pH, but write down the number that you got on here, even if it's wrong, because generally you write down the data you get, even if it's not right. Okay.
Got some more questions.
Okay.
Are you ready?
Yes.
Okay, and you covered this, but it was asked again. Regarding the micro ROV, are there any concerns using an endoscope?
So as it said on the FAQ board, if you look there, no. It needs to be a vehicle. It can't be an endoscope. It can't be anything that sticks out from your primary ROV. It has to be a vehicle that goes into the pipe.
Okay, so for this one, I'm not sure I understand it, but for the shape recognition, does it have to be autonomous, or can we select a region of interest?
So I think I already answered that. If you saw, you know, if you take a screenshot or something, or you need to say, to tell your program, hey, this is the area of interest, yeah, I believe you can do that. And, but you know, again, you can't, you know, it has to be the program that's doing the image recognition.
Yeah, so you could take a screenshot and then load it into your program per se, and then have your program do its magic, right, and output the information, output the total for each shape.
Of course, your other option would be move your ROV to get the screenshot you want. Yeah, might be easier. Okay, so moving on. The next one is transporting and releasing trout fry. So there are going to be 2 trout on the surface side of the pool waiting for you when you get there. And you need to carry these down in some sort of container and put them in the green square. So it does have to be some sort of container. You cannot carry these in the gripper. We are pretending that these are real live baby fish and you don't want to squish them in the gripper. So some sort of container to carry them down and put them in the green square. Now, if on your way down one of these falls out, it's free and gone. It's a living creature. So you can't go pick it up and put it back in here. Once it is out of your container, if it falls out of your container, it's gone and free. Now, if you're moving down, it gets out, and you get lucky enough that it falls in the green square, then you're good. But if it falls outside, even right next to it, you don't get points for that. One of the other questions we had with Ranger, could you use the same container that you carried grout down to carry your trout fry down? Yes, you can, but not at the same time. You don't want your fish in with your grout. But if you dumped your grout and then come back up, put the fish in there, dump the fish, that's fine, or the other way around. You could put the fish in and then do the grout later. Okay, so anyway, these have to wind up in the green square. So the next part, restoring reef habitat, removing a degraded tire. So there is a 3-inch Corex pipe here, connected together in mostly a circle and round. And you have to get this back up to surface. Now there are no grab points on here, so you need to figure out how you're going to get this back up to the surface, grab onto it, and get it back up there. Excuse me, it will have a little bit of weight in it. The maximum weight is listed in the manual, but you know, you need to get this back up to the surface. When you get it back up on the surface, you get your points. Restoring reef habitat, installing a new reef fish ball. Again, on the surface side of the pool, when you get there, there will be a reef ball. This has to come down and go in the orange square, and it can actually go, any part of this inside the orange square will count. So even that, right on the edge, would count. That would of course count, and even if you get all the way in, that's fine. But if any part of this is in this orange square, you get points. Okay? And just another thing, if you can carry down multiple things at once, you're good. So if you can carry down this, the trout fry, grout, you know, if you have a vehicle that can carry down a bunch of stuff, you can carry down a bunch of stuff at once. Okay. So I think that's it for task 2. Moving on to task 3, preserving history. Whew.
I know, right?
Yeah.
Take a drink of water.
Okay, so task 3, let's switch positions, Newman, over here. Yep. It has 2 sections. So there's the doing calculations on the cannon, getting the cannon back up. So essentially recovering the cannon and identifying which of these are cannon shells, metal cannon shells, and which are not metal cannon shells. And you can do either part first. Okay, of course I'm going to do it in order. So we're going to start with the cannon. But one thing is, so what we're testing you with a bunch of measurements and math, and before you commence lifting operations, before you hook onto this, grab onto this to bring it back up, you need to have all your calculations done. If your calculations, measurements aren't done, once you hook onto this, you can't get points for those anymore, okay? So we want those done first. So the first part of this is determining the lift capability of your ROV. So this is something you should probably know anyway, but how much lift, thrust, upwards does your ROV have? So we're not looking for a particular number, you know, we're not looking for, oh, teams have to be over this number. It can be high, it can be low. We just want to know, and we want you to know, how much lift your ROV has. So it's the thrust, upward thrust of your